Hello and welcome to the second lecture for AC 1002 Introduction to Building Technology. This lecture will be looking at location and how that might affect the choice of technology that we choose, and also how we might design buildings to particularly suit individual or different locations. So if we look at where a building is located, we should be able to understand that it has a significant effect on how that building is designed. Buildings in different parts of the world which have exposure to different weather or different seismic activity, different views, different availabilities of materials, and different traditions are built differently. Areas where there tends to be a lot of rain or snow would probably have a pitched roof, traditional pitched roof, whereas in a dry climate, a flat roof is more prevalent. If we go to Japan, we would probably build structures that could withstand or deal with seismic activity, earthquakes. It's not such a problem in the UK, but maybe traffic vibration is. If you're building next to a road, or wind exposure might be if you're building on top of a hill in the Cairngorms. The materials we use are slightly different depending on where the building's located. The construction might be different because we might require different thermal performance. We might need a building to stay warmer in one location or stay cool in a different location. So usually what we would do is we would do a certain amount of site analysis to try and understand or to think about how the building might change depending on where it's located. So what do we need to know? The basic information that we need to know is observable information. This is information that we can get from going to site, looking at site, looking at the conditions that are there, or doing desk-based research to understand what the long-term location effects are. So things like weather, and I'm not speaking about looking out the window and saying what's the weather like right now. This is more of an understanding of what's the general weather pattern. We know that in the northeast of Scotland we tend to have cool to warm summers where it will rain, and in the winters we tend to have slightly milder winters than other northerly countries. So we might not get a lot of snow, and that's from day to day that changes, but over time the pattern's the same. So we need to understand that. We can look at the ground, we can see whether it's sandy, flat, sloped, boggy, and use that to our advantage and use that to make decisions about how elements of the building are put together. We need to understand what the neighbours of the building are like, what the surrounding buildings to your site may be, whether there's any trees, is there any significant views, how do we get to the site for access, and how exposed it is. Is it a sheltered site that has a hillside behind it that blocks or deflects the wind, or is it sitting right on top of the hill and getting battered by every storm that comes past? And that's connected to what the environment's like. A marine environment, so that's something that's next to the sea or indeed within a mile of the sea, is going to be exposed to salt water, whereas an inland environment isn't. With climate, we can consider a microclimate. So that's the conditions in a small area. And that can be a very small area. That can be within a garden, a domestic garden, from one side of a house to the next is going to be slightly different. It's going to be slightly colder. It's going to be maybe warmer on the sunny side. And macroclimate, which is the climate over a larger area. So that might be the difference between the temperature in Aberdeen and the temperature in Ellon. And Once we've observed this information on site, we can apply that to the form of the building. And if we take an example of an area with high rainfall, we'd probably discover that most areas that experience significant rainfall or snowfall have a steep pitched roof. And the reason behind that is that traditionally we don't really want water to be sitting on the roof. The longer water sits on the roof, the more chance it's going to be able to find a path into the building. So to evacuate the water quickly, we would build a pitched roof to be able to push that water away from the building, and it would drop clear of the building. In Middle Eastern countries and warmer countries, they tend to have flat roofs. They're not really concerned with the amount of water sitting on the roof because they tend to get that in a deluge. They wouldn't necessarily have it over an extended period of time. For the site itself, we could have an understanding of what the landscape is, what the form of the building is, what the form of the site is, and make considerations in the design that would reflect that. So for a sloped site, we might look at it and try and establish whether it's going to cause problems for access for construction. Can we get materials from the bottom of the slope to the top or vice versa? But also, once the building's in place, can we access the building safely? Can people who use wheelchairs access a multi-level dwelling? It'll also complicate things like foundation design, in which case we may have to have a stepped foundation to help the building step down the hill, or we might cut out of the hill, cut a series of terraces to be able to make flat areas for building. So severe slopes can cause problems with how we design the building and how we apply the technology to it. Views are an important factor of buildings. We spend a lot of time within a building looking out of windows. A lot of time in architecture school is maybe spent drawing the outside of buildings without due consideration to what you're doing within them. And one of the most important things is what you're looking at. And there's a lot of sites which you would have a fantastic view, but it might not necessarily be in the right direction to make the best of light or solar gain. But the enjoyment of a house is just as important as the technical performance, and it's a balance to make sure that the enjoyment of the house is recognised alongside the technical performance. And for marine environments or extreme environments, we would be choosing our materials carefully. If we are building next to the sea, it's likely that galvanized steel or mild steel will rust away because of the salt within the seawater. So materials that deal with that salt content would be specified. We'd be looking at stainless steel for screws and fixings, other exposed metalwork. We'd probably be looking at maybe upgraded windows that could maybe deal with storms that could come off the sea. We might look at details of the building that make ongoing maintenance easier. So recognition of that location would change the way that we design the building, would change the way the building looks, and would dictate how the materials were specified. Vegetation is an important part of location. So as you go on your site visit, you can look at what the vegetation is. And for any site or a building on a site, trees and shrubs provide a number of benefits. They can shade the building or shade the grounds of the building. They can give visual interest. We can look out of our windows and see interesting colours that change throughout the seasons. They can give privacy to buildings and gardens, create barriers between public areas and private areas, and also provide a habitat for birds and bees and such like. And I mentioned earlier on about microclimate and how we might have a difference in temperature or a difference in the climate over a relatively small distance. And this slide demonstrates that quite well. It's a photograph of a small valley, one side of which is exposed to the south, so it gets a lot of sunlight, which dries out any moisture, therefore doesn't really allow a lot of stuff to grow. And the other side is on a north-facing slope, where the sunlight doesn't reach, the moisture is allowed to stay in between the stones, so we get this growth of ferns. Now the temperature difference across these two slopes is probably quite significant. The humidity difference is probably quite significant as well, even though they are only really meters apart. So when we're thinking about location, there are all those larger issues about where it is, what we're looking at, what the climate might be like, what the exposure might be like. But we have to think about how we actually might build in a location as well when we're trying to understand it. So why is access for construction important? If we look at the site and we can understand the access limitations of a site, it allows designers, architects, ATs to make informed choices about the design at an early stage. You can choose materials or you can choose methods right at the start because you understand the limitations. All designers have a responsibility to design buildings that can be built in a safe manner. So if access is difficult for construction, it can increase the potential for accidents. It's likely that materials and components are going to be delivered on large vehicles. If the roads leading up to a site are particularly poor or inaccessible, then that can restrict access to the site to those vehicles. And if that's the case, we might have to then use lifting equipment to clear trees or other buildings, which really means the use of cranes, which will add significant cost to a project. So we look at road. We would tend to think of site analysis as looking immediately at the site. We go and stand on site and we think about what's there and what we can see. But you've got to consider what happens for some distance away from your site. If we're looking at this image here, this is the sort of road that Jeremy Clarkson dreams of. But I would imagine a guy driving a truck delivering steel beams would probably have nightmares about this. So having an understanding about how you get to the site is also just as important as understanding what happens within the boundaries of a site. Cranes and other lifting equipment may be required depending on the design of a building. If you are designed a building with heavy items, precast stairs or wall panels, we would probably need a crane to be able to lift them, just purely for weight. If there's elements that are awkward, that can't be easily maneuvered by hand or by dollies, we would use a crane to be able to lift them over. And equally, if there's obstacles that we needed to clear that weren't able to be negotiated at ground level, a crane would go over the top. Cranes are very expensive, so if you have to use them, it's best to plan out their use at the start. And that is right at the start as you're thinking about how the building is built and what technologies are used within that. How you might actually get those materials to site should be a consideration. Another example's concrete. We use concrete extensively in buildings for foundations, floors, roads, paths, and basement walls, all sorts of uses for concrete. But these are not small vehicles that deliver it. Most of the concrete trucks require a 3 metre wide opening to a site to be able to reverse in. And the chute at the back on a standard truck tends to have a reach of about 2.5 metres. And on a normal site, if they can get close to where it needs to go, it's a very short distance to be able to drop the concrete into a barrow and somebody to move it there. If it's a long distance away from the actual site, then you may have to spend additional money getting pumped concrete, which the truck will come along with specialist equipment on the back. In extreme cases, it might not be practical to design concrete in a building because of the distance from the depot, in which case you would have to spend additional money on bagged concrete, dry mix concrete, which would then be mixed up on site, which is labour intensive, would probably add cost, complexity, maybe even reduce the quality of the concrete. So the overall distance from a site to the nearest available material centres is an important consideration. Windows are another good example of large elements that need to be thought about when you're building or when you're designing. We would all probably die to have a house with a view sitting right on the beach. I actually think this is probably a photo montage. It looks a little bit odd to me, but if we were to have a house here with nice big windows, that's probably what you would do. You would stick them in. But making that choice for a remote location probably means that windows are going to be triple glazed. They're going to be toughened and laminated to stop somebody walking into them and hurting themselves or smashing the window. And those kind of window units are quite heavy. So it's not unreasonable to consider that a large window, a lift and slide window, is possibly up to 700 kilograms. So that's almost 3/4 of a ton. And it's a difficult thing to maneuver because it's a fragile element. So getting it to a remote location might cost extra money. It might be more complex. The contractor might add in a fee or a cost within there for the risk of doing so. So thinking about that as you design the building is one way that you can minimize or mitigate against those issues. I mentioned earlier on that safety is one of the key considerations for any designer, and keeping the people that are building a building safe, as well as those who later occupy it, is part of the designer's job, part and parcel of the designer's job. And if we can't get to site, if the site is extreme or difficult to get to, it probably means that at some stage we're going to have to manually handle material. We're going to have to lift it and carry it. And over difficult terrain, over sloped terrain, that can be hazardous. That can cause damage or risk damage to the materials, or worse, it can risk injuring any of the workers on site. We also need to consider what safe lifting limits are. The guys that you see in the photograph here are building a wall in Tel Aviv, which I think was actually 1957, so long before we had considerations of health and safety. Nowadays, we would be looking at a safe one-man lift of 20 kilograms, which is about the size of one concrete block. Beyond that, we have 2 people to lift something or mechanical lifting, and that's to save back injuries, injuries from dropping materials. But you can design that out at an early stage by choosing materials which are easy to transport or easy to handle. A couple of other factors that don't directly relate to the technology but you should consider when thinking about location are what skills are available near your site. If you choose a particular form of construction, it could be disappointing or expensive to discover later on that there are not available tradesmen in that area that can do that, and that your team of builders is going to have to come in from a different location. You might also make use of available materials that are available locally, locally sourced timber or stone. And you've also got to think about the waste within the site. How do we get materials that we've not used, offcuts, site spoils? How does that then get removed from a site? In remote locations or even in cities, that can be problematic. So it's not unusual to think before the project has started and while you're kind of busy planning the feasibility stage, to think ahead of where you might put skips and site huts and comfort facilities on a building site before you've even thought about what the building does or how it's designed. So, in conclusion, we need to understand what a location is on in quite a broad sense, to be able to choose technologies well and apply them to a design. And in future lectures, we'll be looking over some technical issues which will relate to location. There's a site analysis lecture which gives you a little bit more information on how you might perform a site analysis to understand some of these factors. So you need to look at those lectures together as a whole. Okay, thank you very much for listening.